Hey Tech Explorers, welcome back to Learning Hub, where we decode the digital world one byte at a time. In the last video, we dove deep into the memory hierarchy. Remember those layers? Registers, cache, main memory, and secondary storage all working together to feed the CPU with data. If you haven't checked that out, the link is in the description. Today, we're zooming in how the CPU actually finds the data it needs within that memory. Think of it like this. Memory is a giant city and the CPU needs a map to navigate it. That map is called the memory address map. So, what is memory address mapping? It's the process of assigning logical addresses, those used by the CPU, to the physical addresses, the actual locations in memory chips. It's like translating street names from a tourist map to GPS coordinates that your car needs. Now, we'll get concrete. Imagine a memory system with 128 words of RAM and 512 words of ROM. RAM is your computer's short-term memory, the place where it keeps data it's actively using. ROM is like a permanent instruction manual. It stores essential boot-up instructions that don't change. Now, our example specifies that we will be using RAM chips with a capacity of 128 words each. To get our total RAM of 128 words, we'll need exactly one of these chips. Because each RAM has 128 words, we need to uniquely identify each word. To do this, we use address lines. Since 2 to the power 7 is 128, we need 7 address lines to address each word within a single RAM chip. We'll call those lines A0 through A6. For the ROM, things are slightly different. We have 512 words of RAM. Since 2 to the power 9 equals 512, we need 9 address lines to address each word in a ROM. We'll label these lines A0 through A8. So, address lines A0 to A6 are used for both RAM and ROM. However, ROM requires 2 additional address lines, A7 and A8, to cover its larger memory space. Now, how does the CPU know whether it's talking to RAM or ROM? That's where memory mapping really shines. We use something called address decoding. In its simplest form, we can dedicate one address line, let's say A9, to select either RAM or ROM. When A9 is 0, we select RAM. When A9 is 1, we select ROM. This is often accomplished using logic gates like AND or NAND gates. So to access a specific word in RAM, the CPU sets A9 to 0 and provides the addresses of word using address lines A0 to A6. To access a word in ROM, the CPU sets A9 to 1 and provide the address using lines A0 to A8. This is a very simplified example, but it illustrates the fundamental principle of memory address mapping. In real-world systems, things get much more complex with larger memory spaces, multiple memory banks, and more sophisticated address decoding schemes. But the core idea remains the same. Translate the CPU's logical request into physical locations where the data is stored. It's the magic behind your computer seamlessly juggles all that information. And that's memory address mapping in a nutshell. If you found this video helpful, give it a thumbs up and subscribe to Learning Hub for more tech deep dives. Let us know in the comments what other technical concepts you'd like us to learn. Until next time, keep exploring.